The design study methodology is a longitudinal user-centered design approach for trying to work with stakeholders to create innovative visualization solutions for their unique needs. While most of what we've seen so far in basic design methods focuses on sketching, user-centered design really focuses on iterating multiple copies of a prototype across the process of learning about a problem, characterizing the problem, implementing solutions, and reflecting on the process to understand how it might drive more effective analysis in the future. In our last video, we talked about the 5 design sheets and other sketch-based techniques. Part of the strength of such techniques is they afford room for iteration. It's really low cost to be able to restart or refine ideas on the fly, and we can use these ideas and these low-fidelity prototypes to really organize and scaffold our conversation with stakeholders, the domain experts who are serving as our end users for our data problems. However, when we're engaged in 5 design sheets and other sorts of sketching techniques, everything is very speculative and short-term. The basic idea behind these techniques is that we are finding ways of quickly facilitating basic conversation and agreeing upon a preliminary solution, but sometimes we don't actually know how successful that solution is going to be until we put hands to keyboards and really start building things out. So to try to address this short-term limitation of 5 design sheets and other sketching techniques, we can use techniques like design study. A design study is a project that analyzes a real-world problem. And in particular, we're working with real-world data, real stakeholders, real experts, real people to try to create a visualization system containing a validated design that we've constructed in conjunction with and in partnership with our stakeholders. After we construct the solution, a key part of a design study is that we can reflect on the lessons learned, both for the domain in terms of how our solution and our techniques and approaches might help future analysis problems, and our own practice in terms of understanding and developing our own maturity as a visualization developer, and learning about interesting techniques, directions, or open questions that we can take into our future professional work. We use design studies to solve a class of problems that are conventionally called wicked problems. Wicked problems are ill-formulated, confusing, you might have stakeholders with conflicting values, the constraints of the problem aren't necessarily well-defined a priori, and quite frankly, we often don't know what it is we're going to find even if we solve the problem. So if you think about this in the context of determinacy versus indeterminacy, determinate problems have definite conditions, are well-scoped problems, and we can design solutions to fit within those constraints and conditions. Wicked problems, on the other hand, are indeterminate, meaning they have no definitive conditions or limits. We have to figure out how do we navigate the trade-offs and conflicts and fuzzy constraints that might emerge in the process of creating a visualization. The design study methodology is broken up into 9 steps. The first 3 of these are the precondition. This is where we learn about the problem. So those phases are learn, essentially doing our homework to figure out what's going on in this problem. Winnow, where we choose the aspects of the problem to focus on and the people to work with. And cast, where we set the project up for success by defining the roles that various members of the team will take in solving the problem. Then we move into the core phase, where we are actively building our solutions. So in the core phase, we're doing our discovery, where we're characterizing the problem more formally according to data and task. We're creating preliminary designs of how we're going to solve the problem, implementing those designs in terms of concrete deliverables or high-fidelity prototypes, and deploying those prototypes with real users to get honest and open feedback about what's working, what's not, and how can we improve. After our solution reaches a satisfactory state, we move on to analysis, where we reflect on the process. And many folks feel that analysis might be somewhat of an academic exercise, but I would argue the alternative. In analysis, what we're doing is we're pausing to reflect on the process that emerged. Part of this reflection is understanding what about the particular solution that we've created offers interesting insight or new capabilities for our stakeholders to work with their data and solve their problems in other ways. And this can even emerge as writing up documentation that provides tutorials or meaningful instructions for using the systems or techniques that we've constructed. And it also is useful in terms of your own professional development, reflecting on what went well and what didn't in terms of both project management and also in terms of your own designs. What new questions or new challenges came up in the process of developing this solution that we might not have expected to encounter or that we don't yet have good answers for? While typically we think of the design study methodology as following from learn step by step all the way through right, one of the interesting pieces about the design study methodology is it's iterative. So the basic idea behind this iteration is that, for example, after we write up elements of our process and things that worked really well, we can go back to the beginning and try to refine our own understanding of the problem space to see if that might offer new and interesting and innovative insight into the process of solving this problem or building tools for a particular application area. In addition, we might decide after we've written things up that we've got a great grasp on the problem, but we want to take this problem now to a new team that may have slightly different perspectives or different challenges that shape the tool in new, creative, and interesting ways. And one thing you will find, just to cut to the chase here, is that this iterative process can occur at any point within the design study. At any point, we may decide that based on the knowledge we have and the discussions with our collaborator, we need to go back to the drawing board and revisit particular techniques, ideas, design elements, roles, etc. that could lead to ultimately a more successful outcome. One potential pitfall with design studies is they are often never done, but you reach a certain point at which you have reached a satisfactory solution that you might come back to iterate on later. Another benefit of the design study methodology is that it is user-centered. So we are consistently interacting with our stakeholders, gaining their feedback, gaining new knowledge about the discipline or the domain, figuring out what works, what doesn't, and creating new questions or tasks or ideas that make their way into the tool. And in fact, there's lots of room in the design study for constant interaction and engagement with the user. In particular, there's an explicit role of our stakeholder in the learn, winnow, cast, discover, deploy, and reflect phases. So these give us concrete, predefined touch points at which we converse with our stakeholder and figure out what's working or not working about our solution. It can be done more often. This is by no means a restriction, but at a minimum, we tend to interact with our stakeholders during these phases. All right, so I've talked about the design study quite a bit at a very abstract level, but what I want to do next is I want to walk through each of these phases in a little more detail to show you an example design study from my own practice where what we were doing is we were working with geneticists to try to build more scalable tools for sequence alignment visualization. So to put this a little more directly, the basic problem we were trying to solve is how can we help scientists understand how the genome sequences of different organisms differ from one another in meaningful ways. And this can be done for all sorts of application, from discovery and drug design to understanding what makes different organisms work, function, and appear different. So we start this with the precondition. And in the precondition, again, we learn about the problem, we explore the literature, we talk to people, we figure out what is the ins and outs of the problem we're trying to solve. We winnow, or we find strong collaborators and strong focus areas that can set us up for success in the ultimate project. And then we cast, we identify what roles will our collaborators play. To break this down a little bit more in terms of the genetics application, in our learn phase, we read about genomic analysis and we talked to a whole lot of geneticists. There were lots of whiteboard conversations about the basic ins and outs of genome alignment and genetics and basics of biology. Once we had a good sense of the problem, then we found a set of collaborators who we could build rapport with and we could converse with regularly and who represented a range of knowledge and application areas that all relied on this idea of analyzing the genome at a low level. After we found these strong collaborators, we cast everyone into roles. As a visualization person, I was more on the development side. I had pure biologists and geneticists who served as kind of our problem gurus. I had computational bioinformaticians who served as critics who would try out the tool and could bridge the language between biology and computer science. And I had co-designers, people who were willing to sit down with me and figure out, all right, something about this design isn't solving the tasks that we need. So from the biological standpoint, what needs to change? And how might the visualization itself be updated as a function of the things that need to change? After we had established that kind of base foundational project management level, we move into the core phase. In the core phase, we're going to really start to dig into the data and the design problems. This is kind of where you get to the things you traditionally think of as a visualization design process. So you start off the core with the discover phase, characterizing the problem in the domain and in the abstract. So figuring out what is the ins and outs of the problem in terms of my stakeholders' language and expertise, and what are the same ideas translated into abstract data and abstract tasks. Then moving into the design, creating our own representations and interactions. This is a great place to do things like plug in the 5 design sheet method to get a really concrete sense of what does a solution need to look like. The implementation, where we actually go ahead and build the thing. And then deployment, where we give it to people to get feedback. So what we did in this case is we started off with this visualization up here in the upper right. This is a tool called MISBE. This was the state of the art prior to working in this problem. And when we were trying to discover what is this problem, what are you trying to do with this data, we wanted to start and say, what are the limitations of your existing tools? And what do you need to be able to do with these tools? What do you currently do and what do you need to be able to do in order to actively solve the problems you're addressing? Then we started doing some sketches, some preliminary mock-ups using co-design and using a lot of whiteboard or sketch-based techniques. I'm a big fan of colored pencils and paper is a great place to start doing these kinds of designs. After we created a series of designs that we were happy with, we constructed a prototype system. So we built a high-fidelity genomics dashboard with real data. You can see this solution, which is called Sequence Surveyor, here in the lower right. And then we deployed it. We gave it to our collaborators, and we got feedback. I started by giving it to people who were close to the problem, but still spoke the computer science language, so in particular our bioinformaticians. And then as we got the tool to a more and more usable state, we deployed it with larger and larger groups of people and with stakeholders who may not share that common computational feedback, but have deep and meaningful expertise in working with the data itself. So people like geneticists and biologists. In general, one thing I want to encourage you to expect is this is going to be a rinse and repeat cycle. Depending on the kind of problem you're working with, it is not unusual for design studies to go on for years. They certainly don't have to. One of the readings for design studies is a tool called Overview, which is a multi-year exploration with many, many journalists in terms of trying to figure out how do we do document mining and text mining at scale for investigative journalism. But there's no reason that design studies can't be scoped to a much smaller time frame. And often when we do these smaller, tighter time frames, for example, over the course of several weeks or several months, the design study is going to involve lots of close collaboration with your stakeholders, and it's also going to involve fewer iterations on the overall design. So once we had finished doing the implementation, we had a satisfactory solution. The next step is to reflect, which is where we confirm or refine hypotheses about our designs or our domain. In other words, we looked at, in this case, what geneticists can learn about the genome now that they couldn't before. And once we figured that out, we went into the writing phase where we summarized and synthesized what we learned from the system. We did this both from a visualization standpoint by offering next directions or new application areas that might be able to use our tool, and also from the biological standpoint to understand what exactly are the patterns hidden in the data. So these kinds of documentation steps are really, really critical, even though they might not involve as much insight on the visualization side, because they offer, again, interesting new next steps. And they also offer us an opportunity to really evaluate and validate that the system is working in practice. For example, one of our validations with the Sequence Surveyor tool was to look at a set of 50 bacterial genomes, which I see here. And what we could find is that by reordering the genes within each genome and coloring them according to their relative position in a particular organism, in this case, bacteria that is an Aphid coli. So this is a bacteria that is found in aphids. So aphids are small organisms, and these Aphid coli have been basically pared down to a very small set of genes over time to try to fit within the smaller space and within the form, essentially, of the organisms that they're working within. And what we could see by doing this is that we could find this set of core genes, these genes over here on the left, that are common to almost every genome in the bacterial genomes that we looked at. But we could also see this long tail on the right, and these represent sets of genes that only occur in one of the bacteria in our sample of 50. And most of these genes are related to specialized functions. These are going to be the things that differentiate, for example, our Aphids coli from our traditional E. coli, or we also had some bacteria that affects agriculture and other kinds of specialized functions in the genomes and in these organisms that can manifest as a result of the data that we're able to filter and isolate for here. So this is one example of a design study kind of end to end. There were many iterations and other things that were hidden that in the interest of time I don't have time to talk about. But I do want to reiterate that design studies are task-centered, user-centered, iterative, and evaluative. So they are task-centered in that you address key questions and goals and you characterize the problem domain with respect to those key questions and goals. They're user-centered in that the stakeholder is integrated throughout the process. We are constantly touching base with our collaborator to figure out, is our knowledge up to date? What's working, what's not, and how can we improve our design? They are iterative in that you can go back and revisit any phase of the design study at any time. And they are evaluative in that you work with stakeholders to see what insights they develop. You can basically have some sort of sense that what you've built actually solves your target problem because you are engaging with the stakeholder and seeing the solutions and the insight in their data they're able to gain through that target problem. So, design studies, as I mentioned, are a very longitudinal process, and I would encourage you to consider many of the stages in the processes of a design study anytime you're engaging with people to build a visualization solution. But what I would encourage you to do for your own self-reflection to try to better understand this methodology is take a moment to pause and think about what are some of the strengths and the weaknesses of this method in the context of different visualization design problems.